So yesterday in class we looked at how to graph a parabola that was given to us in vertex form. Today we're going to look at, well, what do we do if it's not given to us in vertex form? And it is called completing the square. If you were in my class last year, we would have called it the funky zero as well, because we're going to add in a zero, and there's going to be some funky steps into getting that zero. So first, a quick recap of what we did yesterday, and I do expect that you write this note down. If you have graph paper, it will make it a little bit easier. So vertex form is y equals ax minus h squared plus k. This is a very useful form because it tells us where that vertex, which is the highest or the lowest point, is, and it is at the opposite of what's in the bracket, or h, and k at the end of the bracket. And a is our pattern. It tells us if it opens up or down, and it tells us how to adjust our pattern. There's a couple ways to teach the pattern, and if you learned a different way last year, if it makes sense that way, you do it that way. I teach it that because this is a square or a quadratic, it's a square pattern. So if I look at the starting numbers 1, 2, 3, the numbers that go with them are their squares. So 1, 4, 9. So if I wanted to graph a parabola that looked like this, I have y equals -2, x plus 3 squared minus 1. I have all the information I need right there. The vertex is at -3, -1, opposite same. A equals -2, and that gives me two pieces of information. The first, that it opens down, because when it's a negative in front, it opens down. A positive, it opens up. And it's a double pattern because of the 2. So I always start with my square pattern, 1, 1, 2, 4, 3, 9. We never, ever, ever adjust these numbers here, but I'm quite literally just going to double the second set of numbers. I'll create an axis. You can make one that's centered in the middle, but you don't have to. I know my vertex is at -3, -1, and this is going to open down, so I've given myself more room at the bottom. This is my x, that's my y. You have to label a little bit to indicate the scale you're using, because you can't always just assume that it is counting by ones. And so now I'm going to put my vertex at -3, -1, which is right there, and I'm going to go down 1, 2. What that means is from the vertex in both directions, I go over 1, down 2. I go back to my next point, 2, 8. That means from the vertex in both directions, I count over 2, 1, 2, and down 8. 1, 2, 3, 4, 5, 7, 8. And I'll do the same thing in the other direction. These should always be symmetrical. I join it with a nice smooth curve, and that is my graph, so I'm going to label with the equation. So that's just a review of what we did yesterday, because now we're going to look at, well, what if we're given something that looks like y equal to x squared plus 4x minus 3. This is a quadratic, so the graph has to be a parabola, and I know that because of the x squared. Squared means the quad. That's what gives us a quadratic. But this is not in vertex form. This is actually in standard form. So I'm going to do some work, follow some steps to get it into vertex form. So the first step is you always take half of the number in front of x. So in this case, the number in front of x is 4. So I'm doing half of 4, which is 2. Then I take that number and I square it. So step 1 is the 1/2. Step 2 is the square. So in this case, I get back to 4. It doesn't always work like that. Now you're going to make your 0. So 0 is going to always be this number minus that number. So in this case, my 0 is 4 minus 4. The reason why I have to work with 0 is if I add in any other number, I'm changing this. But if I add a 0, even if it looks kind of weird, I'm still keeping this the same size, weight, value, however you want to think about it. So now I'm going to write my question, and I'm just going to leave some room always in between the x term and the constant at the end. So I just separate these two. I don't change anything. Now I'm going to grab the 0 and I'm going to write it in that space. So plus 4 minus 4. And it always goes plus minus. You put the positive one first and the negative one second. Because now I'm really going to ignore the two numbers at the end. I have x squared plus 4x plus 4. This is a normal trinomial with no number in front, so I can factor it. I could go bracket, 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 bracket. And in fact, I will for this one. And then we'll learn how to shortcut it. So I'm ignoring those numbers. I'm looking for two numbers that multiply to give me 4 and add to give me 4. So the numbers are 2 and 2. So my brackets look like x plus 2, x plus 2. This will always be the same bracket. And another way to write it is x plus 2 squared, or times itself. These I haven't used, so they're still at the end, and I'm going to put them together. Negative 4 subtract 3 is negative 7. So now I have negative 7. That's done. This is in vertex form now. So if I were to go graph it, my vertex would be at negative 2, negative 7. My A is 1, and it's a positive, so that tells me it opens up. And it is just a normal pattern because nothing's been changed. I'm not going to take the time to draw the graph, but you should know that. Now, this is a step that we're going to omit when we do it because if we do the numbers correctly, it should always be the same bracket. Let's do a couple more examples. So I'm going to go back and number this example 1. So now this becomes example 2. Y equals x squared minus 6x plus 2. Ignore that. I know it's a quadratic because it has the x squared. It's in standard form, not vertex, so I'm going to do my completing the square. Always half of the number in front of x. In this case, it's negative 6, and I'm going to carry the negative with it. So half of negative 6 is negative 3. So the first step is a half. Now I square it. Negative 3 squared is 9. So my funky 0 is going to be 9 subtract 9, always made up of that number. I go back to my question, and I rewrite everything, but in between the 6x and the 2, I do plus 9 minus 9. Now I cover up, and two numbers that multiply to give me positive 9 and add to give me negative 6 is negative 3 and negative 3, or negative 3 twice, or squared. Negative 9 plus 2 is negative 7. So the first three terms collapse into the bracket, and the numbers at the end go together to give us that. Now, there's a cheater way to find this number right there. This number, if you're careful and you carry the signs, always matches that number. For our first example, it was plus 2 in the bracket, and our first step was plus 2. In this example, it was subtract 3 in the bracket, and our first step of completing the square was minus 3. I'll do one more simple one, and then we'll look at worst case scenario. So x squared plus 10x plus 13. So quadratic standard form, I'm going to complete the square. 1/2 of positive 10 is 5, and I focus on 10 because that's the number in front of x. 5 squared is 25, so my 0 is 25, subtract 25. My 0 gets inserted in between the 10x and the 13. It's always in there, and it's always the positive, then the negative. The first three terms are going to collapse to a bracket with positive 5 in it. So x plus 5 squared, because 5 times 5 is 25, and 5 plus 5 is 10. And then negative 25 plus 13 would give me negative 12. If you're asked to graph, that's when you would pull out the vertex and look at the pattern. But if you're just asked to write it in standard form, then you're done at that point. But on the worksheet, you're asked to graph them, so make sure after you do this, you go through the process that we did yesterday, and like I did on the first example where I actually drew the picture based on the information I was able to get out of vertex form. Okay, those are the steps. It doesn't get any more difficult. You just have to be careful when there is a number in front of the x squared. So in this case, instead of just having x squared, I have 2x squared. So I do have a number in front too. Normally we would common factor it out if we could, and it looks promising there, but the 3 doesn't work. Not a big deal. You are always going to common factor that number out of the first 2 terms only, and I'm not going to take an x out because I'm not trying to factor this. I'm just trying to move the 2 away so that I have the x squared by itself. So 2x squared divided by 2, or factored by 2, is x squared. Negative 16x divided by 2 is negative 8. Now I'm going to leave a lot of room in the bracket because I know eventually I'm going to insert a 0 in there. The plus 3, I don't want to take the 2 out, so it's not going to go inside the bracket. I just throw it at the end. Now I'm going to complete the square, but you always have to work from this step. You never work with the number in front of x while there still is a number in front of the x squared. So I'm going down to this step here. So I'm going to do 1/2 of negative 8, which is negative 4. Oops, sorry. Negative 4 squared is 16. So my 0 is going to be 16 minus 16. And I left room in the bracket. So now I can just go back and insert it right into that bracket. The 2 is always going to be in front. These 3 terms are going to collapse to x minus 4 squared. Remember, I can just grab that number from the first step, or 2 numbers that multiply to give me positive 16 and add to give me negative 8 are negative 4 and negative 4. I still have that positive 3 outside the bracket, but the one number that's still hanging around is this negative 16 because it's not part of the trinomial, so it did not get collapsed into this bracket. I need to bring that negative 16 out of the bracket, and anything inside the bracket needs to be multiplied by 2. All this stuff is still inside this bracket waiting to be multiplied by the negative 2, but since I'm bringing that negative 16 out, I actually have to multiply it by 2, and that's where I get negative 32. So then my last step is just to put these 2 numbers together at the end. Negative 32 plus 3 is negative 29. So my vertex would be at positive 4, negative 29. It opens up because of the 2, and it would be a double pattern. Let's look at one more example with a number in front. So I have negative 3x squared minus 12x plus 5. I know this graph is a parabola because of the x squared. I want to get it into vertex form. The negative 3 is posing an issue right now, so I'm going to take it out. I don't care about the positive 5, so it's going to stay at the end. I'm only going to work with these 2 there. So negative 3x squared divided by negative 3 is just x squared, and that's always what I want, just an x squared. Please be careful with the signs here. Negative 12 divided by negative 3 is positive 4. Make sure when you're dividing, especially when this is a negative, that you take into account that sign and do the division to make sure it would work. Now I'm going to do my funky 0, or my completing the square pattern with this 4. Half of 4 is 2, 2 squared is 4, 4 minus 4. So I have plus 4 minus 4 in the bracket. Negative 3 stays out front. These 3 terms collapse to x with a positive 2 in the bracket, squared. Negative 4 is coming out of the bracket, so since it's coming out of the bracket, it has to be multiplied by the positive 3. So, the negative 3. Negative 3 times negative 4 is positive 12. The positive 5 is still there. These 3 things, we don't have to multiply by negative 3, because they're still in that bracket waiting or touched by the negative 3. So that multiplication hasn't happened yet. The 4 is coming out, this negative 4, so we have to multiply. So my final answer is negative 3x plus 2 squared plus 17. Your homework for Tuesday, remember Monday is the holiday, is to finish the graphing review worksheet that was given out in class on Thursday or yesterday. We did the lines and graphing parabolas that were already in vertex form yesterday. You're going to do all the rest of the questions from that sheet for homework. Tuesday, we're going to review for the test, and I will be collecting that sheet. However, if you have ones that you have questions about, I will answer them on Tuesday.